In this lesson, we're going to be solving absolute value inequalities, and specifically just focusing on ones that are greater than or equal to. So here's what it's going to look like. So we're going to be doing the absolute value of x is greater than 5, for example. So previously, in solving absolute value equations, we're always trying to find out if we could isolate the absolute value. And so we have it isolated. Once we do that, we're going to break it off into two separate equations. So originally, we're going to have x is greater than 5. We're going to write it completely as is without the absolute value bars. And then the second equation is going to have a negative applied to the entire absolute value piece. Is going to take care, and it's going to be greater than 5. So we'll solve each one. This one, done. Our x's can be greater than 5. Here, we want to get rid of the negative. And this is where the inequality part kicks in a little bit, where when you divide by a negative, and we're always going to have this situation when we set up our two equations. And so you're going to divide by a negative, and it's always going to change the inequality and change the sign of the value. So x needs to be less than negative 5. All right, so those are our two solutions. So our x is going to be less than negative 5, or it's going to be greater than 5. So we're going to do two other different versions of this answer. We're going to do a numerical or a number line version, a visual. And I'm just going to focus on our number line that is dealing with the two main points. So negative 5 and 5. And if we graph this, x is going to be greater than 5. We'll have an open circle because we're going to get infinitely close to 5, but not on 5. And any value that's greater than it. And then we want x is going to be less than negative 5. So same thing, open circle, and anything to the left, less than. So we could always plug in values to kind of make sure that this makes sense. So if we plug in a negative 6, what's the absolute value of negative 6? Positive 6, and is 6 greater than 5? Yes, negative 6 works. Positive 6 would work. But any of these values in between should not work. So if we plug in a negative 4, the absolute value of negative 4 is positive 4, and 4 is not greater than 5. So those are the values that don't work. Then there's also an interval notation of this, and I think interval notation is a little bit easier to do once you have a visual. And interval notation is our solutions are, we're going to read this from left to right, our solutions are coming from negative infinity, and we're going to stop at negative 5. And we'll use parentheses because we're not including that negative 5. Otherwise we'd use a bracket. And it's going to be the union. And union represents or. And the second half of our solutions are going to be from 5, but not including it, to infinity. And the infinities will always have parentheses because they're ideas, they're not numbers, you can't stop on them. So our answers are going to be from negative infinity to negative 5, not including it, or, which is union, 5 not included, to infinity. So this is our interval notation, and this is our graphical representation of our answer. So let's do a second one. So the absolute value of x is greater than negative 5. Now with equations we had an issue because we can't do absolute values that are going to equal negatives. But here we're dealing with inequality, so this is a little bit different. So the absolute values, which are always going to be 0 or positive, so everything is going to be, I look at this as positive, are all positive numbers greater than negative 5? Yes. So everything that you possibly plug into this is going to be greater than negative 5. So that means everything works. So it's infinite solutions. And the interval notation of that, so it depends on how you want to write your answer, but the interval notation of that is everything. So from negative infinity to positive infinity. That's the interval notation version. All right, so let's do another. So the absolute value of x minus 3 is going to be greater than or equal to 7. All right, first thing, do we have the absolute value isolated? Yes, we do. So we are ready to separate it into our two separate equations. So original as is Don't change a thing, just drop the absolute value. Second one will have a negative applied to the absolute value term, and we'll solve each one. So here, we'll add 3 to both sides. Our x's are going to be greater than or equal to 10. Here we'll divide by -1 on both sides. You could distribute this through. You'll have to divide the negative at some point anyways, so I might as well just do it right away. And that gets rid of the negative on the left, changes your inequality, flips it because you divided by a negative, and 7 divided by -1 is -7. Add 3, and x is less than or equal to -4. So our solutions are x is going to be less than or equal to -4, or x's are going to be greater than or equal to 10. So visually, we are at -4, +10, and this time we have a closed circle because we're including the -4, and you want values that are less than. And we are including the 10, and we want values that are greater than. So interval notation. Our solutions are coming from -infinity, and we're stopping at -4. But in the previous one, we did not include it because it was an open circle, not equal to. So we'll represent a closed circle with a bracket, and then we are including 10 to infinity. And that is your interval notation version of your answer. All right, another one. So if you have the absolute value, let's say it's 2 times the absolute value, -2 times the absolute value of x plus 4 plus 6 is less than -4. Alright, so just like up here, we're starting to maybe question, do we have a negative over here? Does that mean we're going to get an infinite solution? Maybe. Let's isolate the absolute value first. So we want to get this piece by itself before we start dealing with anything else. So to get that piece by itself, we're going to subtract 6. So that's going to leave us with a -2 times the absolute value of x plus 4 is less than -10. We're still not ready to say that we're going to get infinite solutions yet because we don't have this isolated yet. So we'll divide both sides by -2, and that'll give us the absolute value of x plus 4 is less than 5. This is okay. We can take the absolute value of something. Ooh, I forgot, because we divided by a -2, that flips our inequality. So we have our greater than. But we can take the absolute value and we can get a positive out of that. So we'll set up our two equations. X plus 4 is going to be greater than 5, and a negative distributed into x plus 4 is going to be greater than 5. We'll subtract 4. X is greater than 1, and we will divide by a -1. X plus 4 is less than 4. Subtract 4. X is less than 0. So we have x is less than 0, or x is greater than 1. So visually, we have a 0 and a 1, and we are not including them, so we have open circles, and we want less than 0, greater than 1, and our interval is from -infinity to 0 for this one, and we are not including the 0 because it's a closed or open circle. It's not equal to union 1 to infinity. Okay, and that is our interval notation. All right, one more. So the absolute value of 2x minus 3 plus 6 is greater than 2x So we'll try and solve that one. Very first thing, we need to isolate the absolute value. So we need to get this by itself. To do that, we're going to get that 6 out of there. So we'll subtract 6, and that's going to leave us with absolute value of 2x minus 3 is greater than negative 4. So we have a negative. We've isolated this, so it's going to be a special case. We have to kind of make some sense out of this logically. This is always going to get us a 0 or a positive. So are all positives greater than negative 4? Yes. So that is infinite solutions. Doesn't matter what you plug in, it will be greater than negative 4. And as far as interval notation, it's everything. So negative infinity to positive infinity. And that is solving absolute value inequalities, just focusing on greater than.